Hi everyone. In this video, we would be solving this question, which is frequently asked in Flipkart's machine coding round. So let's get started. So this was the question which was asked in the interview. And by the way, in the machine coding round, the requirements would be given to you like this. And your only goal is to show the output to the interviewer. If you are able to show the output, then you would pass the interview, else you would fail the interview. Okay. So in this interview, the candidates were given the description and the features. So there were total 12 features. Okay. And they were having two bonus features to be implemented. And they have already mentioned that you should only focus on the bonus requirement after you complete these 12 features. If you are unable to complete these 12 features, then bonus requirement would not be considered. So I highly recommend you to complete all the bonus features after you have completed the requirements which are given, right? So let's try to now understand the description and the core requirements. So the requirement is like you have to build the application wherein you would be having patients and the doctors, and the patients would be able to book the appointments to a specific doctor, and you would be only dealing with one single day of data, and the day would be divided into 30 minutes slot, and you only have to deal from 9 a.m. to 9 p.m. Now, in order to understand this stuff, let's check out the features. So over here, they have mentioned the requirements more properly. So let's try to understand this. So the first point says that in that application, the doctor should be able to register himself or herself, and that doctor should be having certain specialty. So doctor should be having one of this specialty. Okay. Once the doctor has registered, the doctor should be able to declare their availability in the slots of 30 minutes. So, for example, if a doctor is available for 9 to 10 a.m., then the first slot would be 9 to 9:30, and the second slot would be from 9:30 to 10. And let's say doctor is available from 1 to 1:30 as well. So the third slot would be 1 to 1:30. And the third point says that the patient should also be able to register to this application. And once the patient has registered, the patient should be able to search the available slots based on specialty. So, for example, if the patient wants to go to cardiologist, so he will just type this cardiologist. All the available slots related to cardiologist will be displayed, right? And those slots which we would be displaying can be sorted in two ways. The first one is based on the start time, and the second one is based on the ratings. Now, the algorithm that we have to implement is based on the start time, and this particular algorithm is in the bonus point. As you can see here, they are saying that you have to implement the rating based sorting. Okay. So this was related to the displaying of the available slots based on the specialty of the doctor. Now, once I check out all the available slots, obviously I would be booking a slot. So patient should be able to book the appointment with a doctor. Okay. And that slot should be available. And a patient can book multiple appointments in a day. But the only thing is no two appointments should overlap each other. For example, if a patient books a slot 9:30 to 10, then obviously that patient cannot book a slot with another doctor, and the slot timing is 9:30 to 10. So both of the slot should not be overlapping. That is the requirement over here. And a patient can also cancel the slot, and if the patient cancels that slot or the appointment, then that particular slot will be available again. And the patient and doctor should be able to view their booked appointments for the day. So these were the 10 requirements, and there are two more requirements. The first one is the patient can also book a slot which is already booked. Okay, so let's say I have booked a slot 9:30 to 10 a.m. of Doctor 1. Now, if you also want to book that slot, then you would be added into the wait list. So that is what they are saying. The second patient who is trying to book the slot which is already booked, then that patient would be added into the wait list. Now, if the first patient, that is the original patient, cancels the booking, then the second patient will get the appointment. So this 2 point clearly says that there would be one slot, and that slot will be booked by one patient, and all the other patient who wants to book this slot will be added into the wait list. If I cancel this slot, then the first one in the waitlist will get that slot. And if this also cancels the slot, then again the other one in the waitlist will get that slot, and so on and so forth. Right. So I hope now all the 12 points are cleared. Okay. Now let's try to come up with entities. So the core entity of this problem is doctor, patient, and booking. And each and every doctor will have the specialization, right? So I've created one enum named specialization, and all the business related logic would be lying into the service layer. So I've created 3 service classes for each of these entities, like doctor service, patient service, and booking service. And all the CRUD functionalities would be lying into the repository layer. So again, I would be having 3 repository classes. Okay. And as we discussed, there should be 2 types of algorithms in order to display the available slots based on the specialty. So for that, I am using strategy design pattern. So this would be the strategy interface, rank strategy interface, and we would be having 2 types of concrete strategies. The first one is start time rank strategy, and the second one is rating rank strategy. And similarly, if we want to add more algorithms in future, we can add that. So this were the entities. And one more thing that I want to highlight is, in order to achieve the dependency inversion, what we generally do is we have the service class and we have the repository interface. Okay. And this repository interface will be implemented by different repository classes. Like let's say SQL booking repo. It means that in this repo, we would be interacting with the SQL database. Similarly, in future, if I want to, let's say, shift to Postgres, then I can just add the Postgres booking repo. Right? And we don't have to change the service layer in that case because we are following the dependency inversion. But in this problem, I am not creating the I repository, or you can say the repository interface. But if you want, you can create that, or at least specify this stuff to the interviewer. And if you are not understanding what exactly I have written over here, please watch my dependency inversion principle, which is one of the solid principle. Okay. So now let's check out the output first, and after that I'll show you each and every classes in our system. So this is the main class. Over here I'm creating the objects of repositories and service classes, and currently I am using the rating based rank strategy. Instead of this, you can also use start time rank strategy. And firstly, the doctor should register themselves to the application, right? So they are registering themselves. So these are the 3 doctors, and these are the specialization associated with them, and these are the ratings. Once they have registered themselves, they are declaring their availability. So Dr. Curious has this all availability. So I am just mentioning the start time. So by 9:30, I mean that Dr. Curious is available from 9:30 to 10, 12:30 to 1, 16 to 16:30, and so on and so forth. The patients can also register themselves. So patient 1 and patient 2 has registered themselves. And after that, they are trying to search all the available slots of cardiologist. Okay. And they are sorting based on the start time, because currently we are using start time. And once they have listed all the slots, they will try to book a particular slot. So for example, patient 1 books a slot of Dr. Curious, and the start time of that slot is 12:30. And after that, the Dr. Curious is checking out all the appointments of the day. And at that time, patient 2 is also trying to book the same appointment which patient 1 did. So in that case, patient 2 would be waitlisted. And when the patient 1 cancels the booking, the patient 2 will automatically get the booking. So let's try to check out the output and understand it more clearly. So initially we are searching all the cardiologists in our system. So these are the slots related to cardiologist. And as you can see, they are sorted based on the time. Okay. Then patient 1 is trying to book this particular slot. So once patient 1 has booked that slot, if the Dr. Curious tries to check out all the bookings of the day or all the appointments of the day, then he would find out this stuff. And when the patient 2 also tries to book the same slot, then that patient 2 would be waitlisted. After that, patient 1 is canceling the appointment. Okay, so in that case, patient 2 will automatically get the appointment. And if the Dr. Curious again tries to check all the bookings of the day, then he would be seeing this stuff. So earlier he was seeing this, and now he is seeing this. So I hope now you understood the output. So let's check out the code. So I've created various packages like enums, exception, models, repository, service, strategy, etc. So let's try to understand all of them one by one. Let's start with enums first. So we have one enum called a specialization, and these are the specialization of each and every doctors in our system. And I've created this 3 custom exceptions. First one is booking not found, second one is doctor not found, and the third one is patient not found. So this is the exceptions, or you can say the custom exceptions, and all of them are extending the runtime exceptions. And I'm passing my custom message which will be printed, okay, when I will be using this particular exception. Now coming to the models, there are 3 models. So the first one is the doctor. Each and every doctor will have all these parameters like ID, name, specialization, rating, and the available slots. So initially this hash map would be empty. Okay. Once the doctor declares the availability, this will be populated. And for each start time, so the key would be the start time, and the value would be true or false. If it is true, it means that doctor is available for that start time. If it is false, it means doctor is not available for that start time. Then coming to the patient will also have the ID and name. And in the booking class, each and every booking will have the ID and the patient who has booked this particular booking and the doctor who would be treating that patient and the time slot for which this booking has been made, right? So these were the model classes. Now let's check out the repositories. So in the repositories, we would be having the CRUD operations, right? And all the CRUD operations would be performed on our in-memory database, which is the HashMap. So this HashMap has a key as the ID of the doctor and the doctor object as the value. So save will basically save this doctor into the HashMap. Find by ID will be fetching the doctor based on the ID, and find by specialization will find all the doctors based on the given specialization. So for that, I am iterating through all the doctors, that is all the values in this hash map, and filtering out all the doctors who has this specialization. Okay. So this was the repository class of doctor. Now in the patient as well, we have the hash map of ID to the patient object, and we have the CRUD operations like saving the patient to the hash map and finding the patient by the ID. In the repository class as well, we have this booking map where we would be performing certain CRUD operations like saving the booking to the booking map, deleting the booking from the booking map, getting the booking by the ID from this map. Okay. And we have these two functions as well. So the first function is find by doctor. So let's say a doctor wants to view all the appointments of the day, right? So I would be passing the doctor ID over here, and I would iterate through all the bookings in this hash map, and just checking whether that booking belongs to the doctor or not. If it belongs to the doctor, then I'm adding that into the list of booking and I'm returning the list. Similarly, this function is for the patient to view their booking for the day. Okay. And yes, so we also have the waitlist hash map, which will help us to implement that waitlist feature. So what I'm doing is, in place of key, I'm concatenating two stuffs. The first one is ID of the doctor, and the second one is the start time of the slot. So for example, if the ID of the doctor is 123, then 123 will be coming in the first place, then hyphen would be there, and the start time, let's say the doctor is available from 9:30 to 10, it means that 9:30 would be present in this key. So this would be the key in this waitlist hash map, and all the persons who are trying to book this slot of this doctor would be added into this queue. Okay, so I hope you understood the waitlist hash map. And related to that, we have two functions. The first one is add to waitlist. So I want to add this patient into the waitlist wherein this is the key. It means that this patient has selected this slot of this doctor. So for this particular doctor slot key, the patient with this ID would be added into the queue. Similarly, in the pop from waitlist, the person who is present in the front of the queue would be popped out, and we are returning the ID of that patient. So I hope you understood this waitlist part properly. Now coming to the service classes. The patient service class will be interacting with the patient repository, right? So the two functions which would be used by the patients are register and the find by ID. For the register, we are creating the patient object and we are saving that patient into the database. So for that, I am using the save function of the repository. Similarly, for the find by ID, I am fetching the patient from the database, or you can say hash map. And if I am successful in fetching the patient, in that case, I am returning the patient, else I will be throwing this particular exception. And In the doctor service class, I will be interacting with the doctor repository, and we have a couple of functions. The first one is register, which is similar to the patient registration process, and I also have this declare availability. So this doctor wants to declare all these slots. So first I'm trying to find the doctor associated with this ID, and if there is no such doctor, in that case I'm throwing this exception. And if there is any doctor, then in the doctor's availability hash map, I am putting the slots and marking them as through. Okay. Now in the booking service class, I will be dealing with three repositories. The first one is booking repository, second is doctor, and the third one is patient. Now we have 5 main functions. The last two are very trivial. So what this two does is, this will help the doctor to view all the appointments of the day, and this will help the patient to view all the appointments of the day. So we are just calling the find by doctor function of the booking repo in order to view all the bookings of a specific doctor, right? And for the patient also, we are using the find by patient function of the booking repo. And I have already explained you this functions, right? Now coming to the three main functions which are required in our application. But before that, let me explain you the strategies. So we have this strategy interface, and this strategy interface will take list of doctor slots, and it will return the same list, but it would be in the sorted format. This sorting would be either based on the start time, or it would be based on the rating. Okay, so let me first show you what exactly this doctor slot is. So this doctor slot is a class where we have two attributes. The first one is the doctor, second one is the slot. You can take this as a pair. Okay, it is, so basically I'm just creating a pair like this, but just for better naming convention, I'm using doctor slot as the name. Okay, because it is storing the doctor details and the slot details. Now let's check out the implementation. So in the start time rank strategy, I am sorting this slot based on this comparator. So I am sorting the slots based on the start time, but before that I am converting them to the local time. So if you remember, all the slot are in the string format. So I'm first converting them to the local time, and then I am sorting them based on the local time. So this will sort them based on the local time in the ascending order and return us. Similarly, we have the rating based rank strategy. So over here, I am sorting based on the rating, that too in descending order. So B is coming first and then A is coming. Okay. So if you are not aware of what I'm doing, I'm using the lambda expression over here. This is slot 1 and this is slot 2. And for a specific slot, I would be having the doctor, right? Because this is doctor slot type. So I would be having the doctor, and each and every doctor would have the rating. So I am comparing them, and rating would have the data type as double. So I am using the double dot compare in order to compare one slot's rating to another slot's rating. And this is in descending order because B is coming first and then A is coming. So I hope you understood the strategy. Now let's continue with the booking service class. So in the booking service class, we have these three main functions. The first one is search, second one is book, third one is cancel. So if I want to search all the slots where the specialization of the doctor is this, then first of all, I am finding all the doctors who has this specialization. So we have already seen this stuff, right? And once I get all the doctors who has this specialization, I will be building this list. So in order to build this list, by the way, I am building this list so that I can provide that to the strategy and get the sorted order, right? So in order to build this list, I am iterating through all the doctors, and for each doctors, we would be having the availability hash map, right? As you can see, each and every doctor has the availability hash map. So for each doctor, I am iterating through that hash map, and based on the combination of the doctor and the start time, I am creating the doctor slot object. So once I create this list, I would be passing that to the strategy in order to get the sorted output. Now coming to the book function, this is the patient who wants to create the booking, and this will be the doctor who would be treating the patient for the time slot which is mentioned over here. So first of all, I am fetching the doctor object based on the ID, and that doctor will have the availability hash map, right? So I'm getting that hash map. Now, if that hash map does not have any slot related to this, it means that that slot has not been declared by that doctor. If that slot is not declared, in that case, I'm throwing this particular exception. And if that slot has been declared by the doctor, in that case, I am also checking if that patient has overlapped that slot or not. That is, if the patient already has a booking from 9:30 to 10, and if he tries to book one more slot from 9:30 to 10, then obviously that should not be allowed, right? Because that is mentioned in the requirements part. So in that case, I am throwing the exception. And again, if this also passes, then I am checking whether the slot is available or not. If it is available, fair enough, we would be creating this booking object and saving that object into the repository and marking that slot as false, meaning that slot is no more available. And if that slot was not available over here, so in that case, I am adding this patient into the wait list. The key of that wait list would be the doctor ID and the start time of the slot. Okay, I have already explained this stuff to you. And in the cancel function, what would happen is we would be having the booking ID as the input. So based on the booking ID, we would be getting the booking object. And if booking object is null, in that case, we would be printing or throwing this exception. And from this booking object, we can also get the doctor, right? Because booking has patient, doctor, and the booking ID. So I would be getting the doctor, and from the doctor, I would be getting the availability, and I would mark the availability of this slot as true. Why? Because I am cancelling the booking. So it means that doctor is again available at that particular time slot. And I'm deleting this booking from the repository. And once anyone cancels the booking, the first person in the waiting list would automatically get promoted. So I am popping that person who is present in the front of the queue, that is this person. So this person will automatically call the book function, right? That is this function, and he would be successful in booking that slot. So this was the cancel function. So we have covered all the functions in the booking service as well. So I hope now you understood each and every classes which are present in the doctor's appointment system. If you did, then please like the video and subscribe to the channel and share this with your friends. Thanks for watching.